we live in a world of geometry just as much as we live in a world of numbers. We surround ourselves with right angles and straight lines. Almost every object around us is symmetrical and made from elementary geometrical shapes. For us, shape and number are quite separate. In Pythagoras' world, they were inseparable.
And we can demonstrate it here by setting it out like this. If we draw
Keith Critchlow argues that we've much to learn from the aspects of Pythagoras we have discarded, and is the architect responsible for completing the largest Gothic cathedral in the world, St. John the Divine, on the fringe of Harlem in New York City. We tend to think of shape as an aesthetic matter, but for Pythagoras, shape, like music, was number.
Pythagoras believed that the world could be explained in terms of mathematics. The world we see and experience had inside it mathematical form. The way we believe he did this was to say that the number 1 could be treated as a point. A geometric point is the number 1. Number 2 could be represented by 2 such figures, and that is the definition of a line. 2 points making a line. So the first relationship is a line. By bringing in the number 3 and 3 points, we get the first shape, a triangle. Now we can bring in the 4th one to make a square by doing this, or we can make it into a pyramid by putting the 4th one on top, and we get our first pyramid.
So Pythagoras associated numbers 1, 2, 3, and 4 with basic shapes: the circle, the line, the triangle, and the square. And for him, these numbers, these shapes, made up the world.
The history of architecture could be seen to be the history of employing these basic shapes that Pythagoras proposed. If we look at this skyline here, what do we see? We see nothing but geometry. May it be occasional tree, but nearly a complete landscape of geometry. It is both its blessing and its disaster. Pythagoras would have been disappointed, let's put it like that, with New York. He would have been disappointed because he said there are 3 shapes which need to be used in harmony: the circle, the triangle, and the square. Now, if we look at this landscape, we see a complete lack of the circle and very, very little of the triangle. Pythagoras proposed that these had a psychological value. Now, the difference between New York we're looking at and the cathedral we're standing on is the cathedral embraces these shapes. It is fundamental to a cathedral, which is a building about the whole. That's what it sets out to be. It is and has to employ these shapes. And that's why a building like the cathedral is a vital necessity to New York. In a sense, the skyline of New York is Pythagorean in the geometric sense. And there are examples within what is basically a right angle and an upright geometry, where we see things like the Empire State Building, which is immensely beautiful because there's a change in shape. And there's other buildings, 1 or 2 in the skyline, and they fulfill another very important role that Pythagoras suggested. It seems strange to us, maybe a little unlikely, but he said that these basic shapes must be kept in balance. Well, the evidence is right the way through architectural history, through the Renaissance, through Gothic England and France. They always employed these basic shapes in combination, and they were healthy at that point. So one could suggest there is the implication of being unhealthy if you only use one shape and you do not harmonize with the other shapes. So another reason why the cathedral here and the dome on the cathedral and what the cathedral will finally be will be an immensely important addition to the whole body, the geometric body of New York.
From our modern perspective, Pythagoras' view of numbers, if we can catch sight of it, strikes us as mystical and somewhat unlikely. But it is at the source not only of how our world looks, but how it works. For it is at the basis of our technology and our science. According to Dr. Atkins, a physical chemist working at Oxford, there's no doubt of our debt to Pythagoras.
Pythagoras opened the eyes of the world. He had a hunch, and it was little more than a hunch, that mathematics would prove to be the key to the description of nature, the description of everything around us. And in the course of 2,000 years, we've come to see that mathematics is the key to understanding just about everything. Pythagoras had the hunch, but it was Newton who turned it into the extraordinary edifice that we have today. Newton was really the first person to show that mathematics could be used to describe the world. He invented the mathematics that he needed as he went along. Well, I would almost take the view that he discovered it. The mathematics was around, and he prized it out of the universe.